consecutive integers and coin problems. That's what it was. Okay. That's where it gets the whole board. Okay. All righty. So let's go ahead and look at this on the front of our packet. It says a jet leaves O'Hare Airport in Chicago at 7 a.m. and flies south toward Atlanta, 606 air miles away, at an average speed of 420 miles per hour. At the same time, a jet leaves Atlanta and flies toward Chicago at an average rate of 500 miles per hour. Because of an error in calculations, the jets are flying at the same altitude and on the same route toward each other. How much time do the air traffic controllers have to change the direction or altitude of the jets before they collide? So what was the thing they asked me there? How much time? So that tells me I am solving for t. Okay, so that tells me that's what I'm solving for. All right, and now, is this going to be a round trip or pursuit, or is it going to be opposite directions or meet in the middle?
Meet in the middle.
So remember, this is round trip or pursuit means I'm doing this, and this is distance of one, this is distance of two, or I have one and then round trip, okay? And then this one, I'm either have one leaving here, and they're going to meet, and I have a total distance. So this is distance of one, distance of two, or I have where they're leaving from somewhere and going opposite directions. So these help me kind of visualize, okay? So I've got a plane leaving from Chicago, and I've got a plane leaving from Atlanta, and they are going this way. So which of these drawings does that kind of help me tune into? It's this one where they meet in the middle, right? So I can go ahead and see, and hey, I know that if I'm using this, then that means the distance of one plus the distance of two is going to equal my total distance, okay? So in this example, I know that I'm going to be using opposite directions here. So I know that the distance of one plus the distance of two equals in my total distance. So let's plug in the information that we know. What is my total distance? What does n equal? What does the problem tell me? How far apart are they?
606 air miles away.
606 air miles away, right? So I know that n equals 606. Okay, let's take the next thing. So I have jet 1, and I'll put C to A, and this will be jet 2, A to C. Okay, so jet 1 has left Chicago going toward Atlanta, and what is their rate? What is the speed of jet 1? What is the rate? 420 miles an hour. 420 miles per hour. Okay. At the same time, a jet leaves Atlanta and flies toward Chicago at an average rate of 500 miles per hour. Now, what variable did I say we know we're solving for?
Speed.
We're solving for time, okay? Because it said what time. The directions say how much time do they have. So what do we know about the time of each of these planes? What did the problem just tell me about their times? They are the same, because it says at the same time. Do I know how long they traveled? No. So I need a variable to represent that. What variable do I want to use? T. So I know that the time of this one is the same as the time of this one, right? So now, what do we say distance is equal to? Rate times time, right? So I've got 420 T is going to go in my distance box. Is everybody good with that? So what's going in my distance for 2? 500 T. Okay. Now I know that I'm using this formula. What is the distance of 1? 420 T plus what?
500 T.
500 T equals what?
920. Oh, wait, what?
606. Remember, the distance of 1 plus the distance of 2 equals n. We already said that n was 606. So now I've just plugged in the distance of 1 plus the distance of 2 equals my total distance. So now what is 420t plus 500t?
Apparently 606.
But what is 420t plus 500t? How do I combine those two? 920t equals 606, right? How am I going to solve for t? Divide by
920.
920. If I divide 606 by 920, what do I get? It's going to be a decimal. What's it going to be?
Big decimal.
Round it to the nearest tenth.
65.
Okay, so if it's 0.65, I'm going to round to 0.7. Okay, if I round to 1 decimal place, that's the tenths place. So now it says t is 0.07. Well, what does that mean? How do we typically do our time? How do we typically, huh?
Wait, is it years?
Okay, we're talking about traveling. So did it take them a year to go? Hours. So when I'm talking about distance, remember we said miles per hour. Okay, so my time is expressed in hours. So this is 0.7 of an hour. How can I find out how many minutes that is?
Multiply it by 60.
Multiply it by 60. If there's 60 minutes in an hour and I multiply by 0.7, that's going to be 0. 6 times 7 is 42. My decimal goes 1 place. So it's 42 minutes is my time. Okay, it seems super complicated, but if you just plug everything in, I plug in the information that I know from the problem, and I know that I'm not going to be able to plug everything in because they're not going to tell me everything or it wouldn't be a problem for me to solve. Okay, so I know I'm having to solve for something. The first thing I've got to do though is figure out, am I talking about a distance of 1 equals distance of 2 problem, or am I having to add my distances together to equal a total distance? That's going to be the first thing. And then that kind of helps me set my mind toward where I'm trying to go. Okay, so sometimes I may have both of these that are the same. Sometimes they may not be. Okay, so let's go ahead and take a look. Flip over to look at number 16 over on our very back page. Okay. Obviously, I've already told y'all that I copied this from the teacher's book, so you already know the answer, but I want you to tell me how to find the answer. No. All right, so I'm going to erase this. I'm going to move these over so they're not right in the middle of the board. So we'll put round trip or pursuit, distance of 1 equals distance of 2. Opposite directions or meet in the middle is distance of 1 plus distance of 2 equals n. Okay. Let's set up our chart. V equals R times T.
So we know the distance.
All right, let's look at number 16. It says Brantley and Shauna walk to Grandma's house at a rate of 4 miles an hour. They ride their bicycles back at 8 miles an hour over the same route that they walk. It takes an hour longer to ride than walk. How long did it take them to walk? Okay,
2
so
hours.
huh?
Has the answer,
2 hours.
Let's try to figure
Genius. All right,
I just
So,
calculated.
you just calculated it real quick.
Yeah.
Walk, then ride is what we're comparing.
So the walk rate is 4 hours.
Okay, so what is my rate of walking?
Yes.
4 miles an hour.
So, and if the rate of biking is yeah, it's just like
8 miles an hour.
See, but I don't know how to think of this, but it's like 4 and 8 are like halves of each other. So if it's 1 hour longer, then I would
Mhm.
get the 2 hours. But
Okay, so think about this. If they left their house and went to grandma's and then left grandma's and went home, what kind of problem do I have? Round trip. So what do I know? Distance of 1 equals distance of 2. Okay. So was it a shorter time walking or riding the bike? Riding the bike. So I'm going to let that be what variable? What variable do I let time be? T. Okay. So my time to ride was T. How am I going to relate? Remember how when we were doing coin problems and I said that when I pick a variable, I have to pick a way to relate everything else to that variable, right? So how much longer than this time did it take to walk? What does my problem tell me? How much longer was it? It takes 1 hour longer. So how could I write this in a mathematical expression telling me that it took an hour longer than T?
T squared.
What would I have to do to that?
And
No, what am I having to do? If my ride time is T and it took an hour longer, it will be T plus 1, right? Because if this was 5 hours and it took 1 more hour, that would be 6 hours. So I'd have T plus 1. T plus 1. Okay, so I've got T plus 1. Now remember, I know that this is going, I've got to set it up to where this equals this, but it's not going to tell me exactly what it is because I got to set up a problem. But what do I know if I multiply these two together, what do they equal? That, right?
yes.
So I've got 4 times T plus 1 and 8 times T. So when I set these up, the distance of 1 equals distance of 2. So I have 4 times T plus 1 equals 8T. Distribute. So 4T plus 8 equals 8T. Everybody good with that?
Yes.
What am I going to move first?
4T.
Move 4T. So 8 is equal to, what is 8T minus 4T? 4T. Divide by 4, divide by 4. T equals 2. So that
That's
means
how the 2
now
hours
it took 2 hours. How long did it take?
That would take 1 hour.
Mm-mm.
Because it said it took an hour longer. 3 hours. No, it says it takes 1 hour longer to walk than to ride. So obviously, no, it would be 3 hours.
They ride their bicycles back. It takes an hour longer to walk than ride.
This is 2 hours. Then wouldn't it be reverse the ride would take
Them to walk to grandma's.
Walk it would take 2 hours. To ride it would be 1 hour.
So what I did,
I think you just solved for walking.
I solved for, so how should I have set this up?
She was actually you were supposed to solve for walking.
Actually, let's see. That should be, what would happen if I did 4 times T? 4T is equal to 8 times T minus 1. T minus 8. That's what I should have done. So let me tell you why I made the mistake I made. What did they tell me I was solving for? Walking. Where should I have put my variable? In walking. That's where I made my mistake, is I should have let T be for walking because that's what they told me to solve for. They didn't tell me to solve for riding. They told me to solve for walking.
I noticed that. I was like,
So what happens if I change this to T? Now I have to relate this part to that variable. How am I going to relate if T is walking? What do I know about riding?
and it takes 1 hour.
It takes 1 hour what?
Less.
Less. So how should I write that? If it's 1 hour
T
less
minus
than my
one.
walking time, what would it be?
T minus one.
T minus 1. Okay. So where I made my mistake is I should have let my walk time be my variable because that's what they told me to solve for. Okay. So that should be T. So now this here, my distance should be 4 times T. 8 should be 8 times T minus 1. So now when I set up and I have 4T is equal to 8T minus 8. Subtract 4T. So I have 0 is equal to 4T minus 8. Add 8. Add 8. 8 equals 4T. Divide by 4. Divide by 4. T is 2. So now this is 2 hours. So what is my ride time? What is T? 2 minus 1 equals 1 hour. So now I know it takes me 1 hour to ride, 2 hours to walk. But where I made my mistake was I did not let my variable represent what they told me to solve for. So it does matter which one you pick, okay? So let's look at number 17. Steve leaves the corner of First and Maple on his bicycle and travels an average speed of 9 miles an hour. 2 hours later, his brother leaves from First and Maple, following him on a moped, traveling 27 miles an hour. How long will it take for him to catch up with Steve?
1 hour.
An hour. Let's see why. What type of problem am I talking about here?
This is a pursuit.
It's pursuit. Good. One person left one place, the other person left the same place, but at a different time. What is my variable, or what am I going to need to let? Let's see, we have Steve, and we don't know his brother's name, so we'll just call him
Maple.
brother. Okay?
So creative.
Huh?
So creative.
Steve and brother. Yeah.
I'm gonna call him Brad.
Huh?
Steve and Steven.
You want him to be Brad? Okay, he could be Brad. All right, so what do we know about Steve's rate? What's Steve's rate?
9 miles an hour.
9 miles an hour. 9 miles per hour. What do we know about brother's rate?
27.
Brad. 27 miles an hour. Okay. Now, what am I trying to solve for? How long will it take for
Time.
brother to catch up with Steve? Okay, we're trying to get Brad to catch up with Steve. So who needs the variable? Brad. And so he will be T. Now I need to relate his time to Steve's. Okay. So think about Steve's time. How much more time did Steve have to travel?
Sorry. Steve had he had 2 hours.
He had 2 hours more time, right? So if Brad's time is T, what is Steve's time?
2 hours. T plus
T plus 2, because we don't know how long it took him. So it would be T plus 2. Okay. So now, how do I know what goes in this box?
T times T. I mean 9.
Right. So I have 9 times T plus 2. What's going in this box?
27.
27T. So what is my equation going to be? 9 times T plus 2 equals 27T. Does everybody see why I decided that? We said it was pursuit. We know that the distances are going to be the same. So the distance of 1 is equal to the distance of 2. We plugged each of them their rates. We said I'm trying to solve for this guy's time. So that's why his variable is T. So we had to relate his time to this one. Now I know that rate times time equals distance. So that's why I put that there. I've set them equal to each other. I've got to distribute. What is 9 times T? 9 times 2. All right, so I'm going to subtract 9T. 18 is equal to, what is 27 minus 9? 18. So what does T equal? 1. T equals 1. So it took him 1 hour. How long did it take Steve? 3 hours. When you first read the problem, you go, oh my gosh, I don't know what time they left and how they went and where they go. You just organize the information into a table. Decide, am I saying that these two added together to equal something, or do these two equal each other? And that's all I've got to do. Let's see, number 20. I heard y'all whisper it. Who was it? Who was it? Everyone's like,
It's so cold.
okay. See, before y'all know it, y'all gonna be like, man, these are fun. And we're gonna keep doing them until I hear somebody go, man, these are fun.
These
Oh, these are
fun.
fun. I love these.
A passenger train leaves Charleston, West Virginia, heading east at the same time as a loaded coal train leaves Charleston, heading west. What kind of problem do I have?
The train.
Opposite.
Trains. I have here, we're in Charleston. This is Charleston, West Virginia. And I've got one going west
Opposite.
and one going east. Okay? So I know that's what it looks like. And it says, the passenger train travels. So let's see, passenger train goes west. So this is our passenger train, and this is our coal train. Which one's going to go faster? Passenger trains.
Train is going 23 miles per hour faster than the coal train. And
Okay. So it says that my passenger train is going 23 miles an hour faster than the coal train. So which one should be my variable T? Coal, we'll let coal, passenger train, coal train. So this will be T, and my passenger train will be T plus 23.
Oh, in
No, that's not right. Good grief, not time.
There's a little more.
Rate.
It says that in 4 hours, the two trains are 112 miles apart.
Okay, so where should my rates go? My coal train is R. So what is my passenger train?
Is
R plus 23, because they said it's miles per hour, right? So I know that that tells me, what was my time?
4 hours.
Okay, so it says, and in 4 hours, the two trains are 412 miles apart. So what do I know my time is? How many hours did it just say? 4 hours. So my time is going to be 4 hours. Okay, they're both going to be 4. What is my total distance? What is N? 412 miles apart. Is everybody good so far? Charleston, West Virginia, coal train, passenger train. We're trying to figure out when they're 412 miles apart. So what does that mean? D1 plus D2 equals 412. How do I know what's going to go in this box?
That times that.
4 times R plus 23. What's going to go here?
R times 4.
4R. So my distance of 1 is 4 times R plus 23 plus 4R equals 412. I'm going to distribute 4R plus 292 plus 4R equals 412. 4R plus 4R is 8R plus 92 equals 412. Subtract 92 from each side. 8 R is equal to 11. 2 minus 2 is 0. 11, that would be a 2. 320. Divide by 8. Divide by 8. R is equal to
63.
Did I subtract wrong? 412 minus 92.
It's 320.
Come on, open calculator and phone. 412 minus 92 is 320 divided by 8 equals divided by 8 is 40. Okay. So what does that mean? What did I solve for?
The Coltrane's rate. You didn't.
I've got the Coltrane's rate. So if this is 40,
40 plus 23 is.
then what is this one?
63. So that's
This
what
one's
we got.
63. So what am I trying to find?
Well, you're trying to find the speed of each train. You just
Okay.
found the speed of
The speed of each train. So we found that the coal train is 40, our passenger train is 63. Okay. So by knowing that I'm setting up the distance of 1 plus the distance of 2 equals 412, by knowing my distance formula is D equals RT, distance equals rate times time, I plug in what I know. Now again, I'm having to multiply these two together to find this using variables. I'm not going to have just a number here, okay? So then I just plug them in. Let's look at 21. A roller coaster goes down the first grade 8 times faster than it goes up the other side. So, okay. The distance down is 100 feet more than the distance up. And it takes 70 seconds to go up and 10 seconds to come down. What is the speed in feet per second of the roller coaster when it goes up and when it comes down? And oh, looky, we don't have an answer on this one. Oh, no.
I think she did that on purpose.
So let's think about this one for a minute. I've got roller coaster. Anybody in here like to ride roller coasters?
Yes.
Yes. Anybody gone to the fair yet?
No.
Anybody going to the fair?
No.
No.
I'm going to Disney.
Well, yeah, I guess you don't want to go to the fair if you get to go to Disney.
Well, I've technically I've been there, but I didn't get to go. All
right, so we have our roller coaster. All right, we have our roller coaster and it goes down and up. Okay, so how do I know what kind of problem is this going to be?
It's a.
It'll be like round trip. Okay, so think about it. It's just facing upward. If I turn it sideways, it's going to look the same. So I've got the D of 1, D of 2. So I know the distance of 1 equals distance of 2.
Distance down is 800.
Okay. So it says a roller coaster goes down and up. Okay. The distance down is 100 feet more than the distance up. So which one am I going to let be D?
The D because it's distance down.
Well, but it says the distance down is 100 more than. So how can I relate that? If it's 100 more than, what does that mean I'm doing?
Plus 100.
D plus 100.
And up should be D, I guess.
Okay. So it says the distance down is 100 feet more than the distance up. And it takes 70 seconds to go up. So what's my time? 70 seconds.
Wait, no, it takes 70 seconds to go up. And
Yep.
then it takes 10 seconds to come down. So it's
70 seconds and 10 seconds. What is the speed in feet per second of the roller coaster when it goes up and when it comes down?
So we're finding the rate.
Okay, so I need to find what is the speed in feet per second of the roller coaster when it goes up and when it goes down. So let's see. Down the first time. Oh, what is my rate? The roller coaster goes down the first grade 8 times faster than it goes up the other side. So my rate goes down 8 times faster than it goes up. So if this is R and this is 8R. Now, what do you notice that I've got going on here? I've got 2 variables. I've got a problem here. I got to figure out how to relate these. How can I do that? What can I do to make these relate? What have I been doing with these each time to find my distance? I've been multiplying these 2 together, right? So basically, if I multiplied these 2 together, that could equal this, right?
Yes.
So instead of this being D, what would it be?
70R.
70R. Okay. And what if I multiply this together, but I also have to incorporate this information? Yes.
D plus 100 parentheses 80R.
Okay.
Parentheses.
So
80 plus 8,000.
tell me that again. Hang on. Tell me again what you just said.
Me?
Uh-huh. What did you tell me?
D plus 100 parentheses 8R. I mean 80R. No,
So really this is this, right? So you're saying 8R times 10,
Yeah.
80R, right? Is the same as that, right?
Oh.
So I'm
yes.
saying I've got 80R plus 10, plus 100.
Yes.
Okay. So if I have 80R plus 100 equals 70R, because of these 2 are equal to each other.
Yes, sir.
So I subtract 70R, subtract 70R, so 10R equals, that's not gonna work, hold on. First of all, let me ask you this. Before I even go into all that, what do I know if this is 70 seconds and this is R?
They're equal.
How can I find my rate?
Well, it would 70R. It would be 70R equals 70R.
What is the speed
and
in
then
feet per second? 100
It's
feet
1.
more. It goes down the first grade 8 times faster than it goes up the other side. So we know 8 times the rate.
Oh, wait, no.
The distance down is 100 feet more than the distance up. The distance down.
Wait, it's 0. Because.
But wait, our distances are not the same, are they? So what's the problem here? We're trying to make these equal to each other and they are not. Because notice it says the distance down is 100 feet more than the distance up. So these are not equal to, so this is not, so it's not the same because one has a bigger distance than the other. Because think about, if I have a roller coaster and it goes down like this, it might go up like that. So it's a shorter distance down than it's going up. So this one it's not necessarily my up and down are not going to be equal to each other.
I think they didn't put the answer down because they didn't know.
You think it was because they
That's-
didn't
I
know?
thought about that too. I was like,
Okay.
because that's
Maybe
not
they
what I
didn't
just.
do it when the roller coaster.
Maybe it's because I want y'all to be challenged and think through this. Okay.
Did you take the answer?
Huh?
Did you like scribble out the answer?
So let's think about this a little bit more. Let's
Well, I
figure
just see,
figure out
like,
how
something
to,
that looks like it was missing my head. Maybe she took a whiteout marker.
let's think about it for a minute. Okay, goes down the first grade 8 times faster than it goes up. The distance down is 100 feet more than the distance up. It takes 70 seconds to go up, 10 seconds to come down. Okay. So think about
That's weird.
speed of feet per second on the roller coaster when it goes up. Speed, we're trying to find the rate.
Not do that.
More than. The distance up. Oh, y'all know why this is messing me up? This is the third type of problem that we haven't got. Remember when I told you we were going to only go through the first and second? This one is actually D of 1 is equal to D2 plus N. What is N in this problem? So in this problem, it says a given distance must be added to a shorter distance to equal the longer distance. Okay? So in this one, I've got the distance of 1 is equal to the distance of 2 plus N. So that's why it's messing us up here, because our distances are different. This down is distance plus N. Come back and we're gonna get this one finalized.
I know. Yeah.
I don't know what you said. Or you look it up on Google and you say
All right. So this one N is 100. So our distance of 1 is 70 R is equal to 80 R plus 100. Okay, which one? The distance down is 100 feet more than the distance up. So my distance down, so my distance down, so it's, I've got them flip-flopped. So down equals up plus 100. So down is 80 R equals 70 R plus 100. Subtract 70 R, subtract 70 R. 10 R equals 100. Divide by 10. Divide by 10. R equals 10. So you're going 10 miles an hour. No, feet per second. 10 feet per second. 10 feet per second. And this is 80 feet per second. There we go. That's why I didn't have that problem circled, is because it doesn't relate to the two that we've been working. And I just decided to jump and, hey, let's do that one. I guess that's what happens when I go off plan.
Yeah, my bad days tomorrow because I have to watch my sister on my own completely for like a few hours because my parents are going to town for a brother and senior today. I meant to go get a piece of phone. Let's do it.
Oh dear. We had rehearsal on Thursday, rehearsal on Saturday, rehearsal tonight, tomorrow.
All right. So let's go ahead and take a look at this. Like I said, that's why I had not circled this one because it did not relate to the type of problems that we were focusing on. It was one of the ones where I had to have the distance of 1 is equal to the distance of 2 plus 100 or plus a distance. So they told us that 100 is our additional distance. And we said we know that down, my distance down equals up plus 100. Okay. So if down is equal to up plus 100 and down is 80R, then 80R is equal to up 70R plus 100. Now I subtract 70 from each side and I get 10R is equal to 100. Divide both sides by 10. So my rate is 10 feet per second. Therefore, my rate going down is 80 feet per second. That's pretty fast. Okay, so it's going down at a rate of 80 feet per second and going up at a rate of 10 feet per second. Okay. Questions? Comments? The main thing though is figuring out, and y'all will be doing more of this in Algebra 2.
I wrote it down. What is the rate that goes up?
Okay, so we said that if R is 10, and we said that our down rate was 8 times R, then that means my rate going down is 80. Okay, so my rate going up is 10 feet per second. So down is 80 feet per second. Okay, so the main thing to remember with distance problems, and so like I said, next year you'll be, or not next year, or grant for you next year. Next year, year after next, when Algebra 2, you'll be seeing more of these types of problems. Just remember that distance equals rate times time. I set up and I plug in what I know. I solve for what I don't know. Now, there are additional problems where it'll talk about like a plane left and it has a headwind and a tailwind. So think about a headwind is when you're flying into the wind. And so what would that do to an airplane? If it's flying into the wind, what does it do to its rate? It slows it down and it has to fight against that. But if it has a tailwind,
it pushes it back.
It pushes it forward. It makes it go faster. So there are also distance problems where you're having to look at headwinds and tailwinds. And say that again.
Yes, right.
We said the rate, if R is 10.
7 seconds. 70 seconds go up and then.
Right. So if it's 10 feet per second, then what would our rate be? It would be 70 feet. No, it would be 700 feet in 70 seconds. Okay. All right. So just remembering, you can always set up a table. You can plug in what you know, what you don't know to be able to solve. Okay. Now we're going to shift gears again. Y'all ready? Let's go back to our book. All right, so we had originally said we needed to finish up on several things. So we looked at our coin problems. We've done distance and motion. We've done ratios and proportions. Now we are going to shift to lesson 119 and 120. So turn in your book
There's a person.
to page 261.
Zoe for a hot second. Zoe for a
hot second.
Of course.
No.
Really?
Wait.
I think I have like a what are those things?
Can you still
I think all
I think there is.
20. Well, I have a first time. I don't know where the next part.
$20, you erase the whole board. I mean, it's the end of the year. You can't get kicked out.
Not yet. We have another day.
She already finished.
I think probably.
I like it too.
That's chocolate.
Is that $1?
That's gonna die.
Oh, is that $2? Oh my gosh, on my video.
Oh my gosh.
I mean, if you erase it right, then it'll leave it.
Erase the top
right.
No, don't erase
Don't
that.
erase that.
Don't erase
Don't
it.
erase the
No.
face.
No.
Settle down.
You killed him.
Who wrote that?
Me.
Oh. It's
I
on
did.
science.
I did that
Erase
one
that
and
one
one in
too.
science class.
Yeah.
Okay, erase that
No.
one. Don't kill his twin.
I'm sorry for your loss.
I was wondering how long it's been on there. 2 weeks straight.
Oh.
Oh my God, everyone, calm down.
can't get it open.
Take all the
I'm trying not
markers.
to.
That's not very smart. It doesn't seem like
That's a mouth face.
There, that looks weird.
What's his name?
I got a name set.
That's mine. That's me. It's too bad you can't erase them. It's a video of me shooting myself.
Okay, shut up. I don't care.
I was like, oh. And then I just dropped my pencil.
Hide them.
He was like my skills up, and then I
I'll do that.
told my grandma.
Red.
No. Like a move. Oh my god. So, you just like have it already. You just go.
Oh, it's going outside. Oh. They are spilling.
And then I'm like, they are spilling.
Like, you're just like, It's a geocache. Geocache.
I fixed the bowl. I fixed it so bad.
I need more water. I should like go back.
Like, go get some water, like.
I just need the water. I'm just gonna stay right here.
What? Really?
Yeah, I was.
Why does it look like that?
There was literally one water person. And right in the deep cross.
Okay, no.
Oh, I thought you said you weren't gonna drink it.
I don't.
She doesn't, but.
I can just see that.
I don't like her.
Science, literally, we just have 2 hours. We didn't have anything else to do. Our back kid will play Texas, the Oakland game.
Today we're just.
Really?
We don't have any.
All righty. Lesson 119, page 261. Notice this is called direct variation. Page 263 is inverse variation. What? Do I have a kick me sign on my back?
No. Nothing's wrong. Like, just keep teaching. Like, we need to know this information.
Yes, you do.
So just keep teaching.
Thank you, Evelyn.
I know. Like, what are these people doing?
I don't even know.
Like,
What are
stop.
they doing? I
She's
mean,
trying to teach.
You erased my smiley faces.
I do believe my erasers are gone.
Oh, wait, why are we on markers in the line?
I don't know.
I don't remember that.
And y'all know I'm not afraid just to use my hand. All right.
Oh, she erased it anyway.
What was it?
I don't
I
know.
erased what anyway? Oh my goodness.
You could have got 20 bucks.
I could have got $20.
No, I couldn't. She told me to
erased
erase
all of
them.
it.
She told me if I erased everything, I'll get $2, and I thought you'd be mad. So I didn't. Actually, I erased the slope and then redrew it. 'cause I was missing.
Now what you doing? I had a marker up here and now it's gone.
I see that there was.
And there's my eraser in front of it.
What? No, what?
All this time.
Stop it. What are you doing?
Oh my goodness. I step out for just a minute and lose all control.
It was
Here, I'll be the nice one and give it back.
So now when I go take fingerprint, because I'm gonna go to, who's the forensics teacher? I'm going and taking fingerprints to see whose fingerprints.
Just
is
don't
touched
watch
this
the
marker.
video.
Just don't watch the video. It's all on the video. Those of you at home watching know who was against me.
Wait, are they watching?
No,
Are there's
nobody's
actual
watching.
no?
We've just got a couple that may watch it. Claire. I'm just gonna tell me. Claire will tell me. I don't know about Chad. Chad might or might not tell me. Okay. So
How Chad was the one that stole it.
Chad did it. Okay. So one of the things I want to tell you guys, lesson 119 and 120. Okay. Variation. And lesson 120 is called an indirect variation. All right, so right now I have no clue what either of these are, but what do I know from hearing the word direct and indirect? What type of words are these? They're opposites. Great. Yes, so I know, hey, I've got opposites going on here, okay? And so what it says in lesson 119 says a linear equation is one in which one variable is a multiple of another variable. Is known as a direct variation. One variable varies directly as the other variable. In other words, as one variable gets larger or smaller, the other variable gets larger or smaller at the same time. So when I talk about a direct variation as one the other gets larger, or as one gets smaller, the other. As one gets larger, the other gets smaller, or as the other gets larger. This is going to be something that you will see in a lot of as you go through science classes, as you look at charts and graphs and data. And I know this is one of the things that dealing with charts and graphs and data is one of the things that a lot of people, as I'm working with ACT students and doing ACT prep, science is not content knowledge. It's not. There are some things you do have to know, but the biggest part of it is reading charts and graphs. So one of the first things that you do is you sit down, as you look and say, hey, if I've got a graph that looks like this, and I've got numbers going up this way, and let's say this is 10, 20, 30, 40, and this is 5, 10, 15, 20. Is my graph looking like that? Whereas this one is getting smaller, this one's getting larger, so this would be an inverse, okay? If this was my line, as this number goes down, this number is going up, so that would be an inverse, okay? Whereas if it's going like this, I can see that as this increases, this increases. So I can see it's a direct variation. So by understanding, and so think about our slopes of our graphs. Think about when we were graphing and we talked about a positive slope and a negative slope. So we can see that as one gets larger, the other gets larger. Or if it did this, notice that this one, my number is getting smaller, and this one, my number is getting larger.
Bless you, bless you.
Okay. So thinking about being able to understand direct and indirect variations talks about as one increases, the other increases, or as one decreases, the other decreases, or is it an opposite direction? So the formula that we use for direct variation, remember we said when we're talking about two variables, we're talking about graphing linear equations. What are my two variables that I deal with linear equations? When I'm graphing a line, what are my ordered pairs that I have to plot? X and Y. So I'm talking about if I have X and Y, okay? So my equation for this is that if I look at Y is equal to K times X, and K is my variation, okay? That's called the constant of variation, okay? So let's look at an example of this. So notice in our purple box underneath, it says if Y varies directly. So when it says varies directly, that's meaning direct variation. So it says if Y varies directly with X and Y equals 27, when X equals 9, what is K? So I've got my equation where Y equals K times X. What two things do I know?
Y and X.
I know Y is 20 times 9. How can I solve for K?
Multiply by 9 and divide.
All I've got to do is divide by 9.
Yes.
So what does K equal? 3. So it means it's going up by 3s every time. My constant of variation is 3, okay? So that's all we're doing is saying, hey, Y equals K times X. If I know 2, I can solve for the other. I can find the direct variation. Look at lesson 120 over on page 263. Now we're talking about inverse variations, and this formula, if it's an indirect variation, Y is equal to K divided by X. So Y is equal to K divided by X. With my direct variation, it's K times X. Indirect, K divided by X. So let's look at the example of this one. It says, if Y varies inversely, as as x and y equals 4 when x is 3, what is the value of k? So it says y equals 4, x is 3. What is k? So I just plug it in. 4 equals k over 3. How do I get my number out of the denominator? I've got to multiply. What's 3 times 4?
12.
So what does k equal?
12.
So if it's in a direct variation, y equals kx, I plug in my 2, solve for k. So basically in this situation, when it talks about graphing these, it says an inverse variation always forms a special type of graph called a hyperbola, okay? And that'll be something you will see in Algebra 2. Algebra 2 is a lot of graphing, okay? You're going to be looking at parabolas and hyperbolas, and it says it's a conic section much like a parabola, but with 2 broad U-shaped curves in opposite directions. So usually you're going to see something like this, or like this, where they're going in opposite directions, okay? So like I said, I just wanted you to have heard these terms, know that a direct variation, they're going in the same direction. Doesn't matter if it's up or down, indirect, opposite directions. Those are the main things to remember from direct and inverse variations. And that's it on that. Pretty quick and easy, huh?
Yay.
All right. Let's look at lesson 131 and 132. 131 is over on page.
What that will actually skip a
286.
131 is on 289.
Oh, wait.
This is
we
really
X'd
good.
out. Yeah, we X'd that out.
We
You
X'd
can't
out.
do it.
And 132, I just want to talk about it for just a minute. X, I know, we did, but I just want to say something about it, okay? We're not doing these sections. I just want you to know exponential growth functions. What do you think your numbers are going to do?
They're gonna grow.
They're going to grow by a lot, because what is the word that comes before growth? Exponential. So when we talk about something growing exponentially, it means that we're using an exponent. We're multiplying by an exponent. And so we know that when we have exponents, even if it's just an exponent of 2, I know that if I have 4 to the second power, it's not just growing, it's not just doubling, it's growing exponentially. It's going to 16. It's growing by the whatever the base number is by itself. So when we talk about exponential growth and exponential decay, I'm talking about numbers that are growing exponentially or based on what the exponent is, okay? So that's why I just wanted to mention that. Again, that'll be something again that you'll see in science classes as well as higher math. Now moving on to lesson 136 on page 299. Work problems. Since everyone loves to work, I figured y'all would love this section. Okay, so it says work problems involve 2 or more people or machines working together to accomplish a single task. To solve work problems, set up an equation using fractions that show what part of the job each individual can accomplish in a given unit of time. The sum of the individual fractions is equal to the part that can be accomplished in the given unit of time together. So let me say that again. The sum of the individual fractions is equal to the part that can be accomplished in the given unit of time together. So here's our example. If Mike works on a landscaping project alone, it takes him 4 hours to do the job. Dave can finish the same job in 5 hours. How long would it take for them to do the job together? Okay, so let's break this down for a minute. So in these situations, I know that I'm always going to let my job be J. Okay, I'm going to set up a variable to represent my unknown. All right. So I'm letting J be the time to complete together. Okay. So I'll put job together is J. right? And so what did that sentence that I read twice say? What's the last sentence in the first paragraph? The sum, what does sum mean?
Total.
Total, which, how do I find the total? Addition, add. Okay, so I'm going to add the sum of the individual fractions. So add fractions of individuals. You may.
No.
The sum of the individuals is equal to the part that can be accomplished together. So basically, I'm saying I add the fractions of my individuals. So if it's 2 people, how many fractions do I have? 2. Okay, so I'm going to add my 2 together to find the job, my total job. So here we say that we have Mike. And who else do we have?
Jay.
Dave.
Wait, Dave, sorry.
Okay. And so we said it takes Mike 4 hours and it takes Dave 5 hours.
Ooh, makes sense.
Fractions of those.
Now, those are not fractions, are they?
Yeah, but you can make
So I've got to set up my fractions.
1/4 and 1/5.
Why?
Because it's a fraction of each.
So think about, this is 4 hours. So if we're talking about time, how are we wanting to express time? In hours, right? So I'm saying that, so Mike, how much could he complete in 1 hour? Okay, so that's what we're looking at. So if I look at, in 1 hour, Mike could complete 1/4 of the job. Does that make sense? Okay, so he can complete 1/4 of job in 1 hour. How much could Dave complete?
1/5.
1/5 of the job
Add those together.
in 1 hour. Okay, now we know the job is going to take more than an hour, right? So if I'm trying to find how much it would take per hour, then 1/j is going to be my fraction for job. Does that make sense? So I know that 1/4 plus 1/5 equals 1/j, because I'm trying to find out per hour. So he can complete 1/4 of the job in an hour, 1/5 of the job in the hour. So I'm going to set that equals to 1/j. What do I do when I add fractions? What do I have to do when I add fractions? What has to be the same?
The denominator.
Denominators have to be the same. I have a denominator of 4 and a denominator of 5. How do I figure out what I want to use as my common denominator? Why?
You can multiply them together.
Yeah, the easiest way, I can either find the least common multiple and say, hey, what are multiples of 4 that are also multiples of 5? And in this situation, it's just multiplying them together. 4 times 5 is 20. That is my least common multiple. Okay, so I know I'm going to have something over 20 plus something over 20 equals 1/j. Okay, so what am I going to have?
5/20 plus 4/20.
Okay, so that means I have to multiply this one by 5, so this has to multiply by 5. This by 4, this by 4. All right, is everybody with me so far? But notice that I've got 5/20 plus 4/20 equals 1/j. What is 5/20 plus 4/20? 9/20 is equal to 1/j. Well, how do I solve for j? I can cross multiply, can't I? So if I have 9/20 is equal to 1/j, that means 9 times j is equal to 20 times 1. Everybody with me so far? Divide by 9. Divide by 9. J is equal to. So let's look at 9. We'll go into 20. 9 times 9, not 9 times 9, times 2 is 18. Subtract. That's going to give me a 2. Bring down. I've got a 2 point something. 9 will go into 20. What do y'all see is happening here? It's going to be repeating. So I've got 2.2 repeating. So in this situation, if I've got 2.2 repeating, what do I know that this is telling me? What is my 2 before the decimal telling me? But what period of time am I talking? Hours. So I know it's going to be 2 hours. But how can I figure out my minutes? Huh?
Use the point too.
Use the 0.2, and what am I going to do with it?
Put 9 under it.
Okay.
Multiply by 60.
Multiply it by 60. So what is 60 times 0.2? So how many minutes is that?
12 minutes.
100.
Okay. So they just set it up to where they cross multiplied 2 over 9 equals x over 60 minutes. So 9x equals 120 minutes. So they said 13.5 minutes. So with us rounding to this 0.2 repeating, that's why it is a smaller number, because it was actually 0.2222222 that I'm not actually multiplying by. So you get a good estimate of what your time is. You don't have to do the fractions like this when you're doing your jobs. You can actually, so about 2 hours and 12 minutes. If it took somebody 2 hours and 13 minutes, I'm not gonna go, oh my gosh, it took me a minute longer. So you're in the ballpark, okay? But you can see that together, it took him 4 hours to do it by himself, him 5 hours to do it by himself, but together they could do it in just over 2 hours. So that's what work problems are. I set up a fraction to represent each individual. And what I do is I look to see how much of the job could they complete in 1 hour. So he did 1/4 of the job, he did 1/5 of the job, and then 1 over j is going to be my variable. So let's look at classwork, page 299. If it takes one Zamboni operator 6 minutes to resurface an ice rink, it takes another Zamboni operator 8 minutes to resurface the same rink. How long would it take the 2 Zamboni operators working together to resurface the ice rink? Now, this is what I don't know. Have you guys, y'all know what a Zamboni is?
No.
Okay. Has anybody ever been to see the hockey games, ice hockey? Or everybody ever been to go ice skating? Okay, so
Like
Is
clean
it,
it,
is it
right?
one of those?
It's like one of those
machines that have
machines
brush?
that
Oh, I know.
runs
I
over
know.
ice
It's
cream.
from Yes, all the big things.
Yeah, when we went,
Yeah.
one of the-
Yeah.
Oh, yeah, he messed up just a
Yes.
little.
No.
okay, so basically it's the big machine that rides along the ice and it resurfaces it.
Those are so cool.
It rides around, it goes in circles to smooth out the ice. Okay, so that's what their purpose. And so what they'll do is actually it kind of squirts out a little bit of water. What's the purpose of doing that?
So it
To
refreezes
refreeze it smooth. Okay, so it's not like they're trying to shave off the divots and stuff, because think about ice skates are going to cut into the ice. And so the purpose is for it to kind of go over, it squirts out a little bit of water, freezes it, makes it a nice smooth surface.
You want
okay.
more layers.
Now, the only thing, I mean, and of course, the practical side of me goes, well, first of all, can 2 Zambonis fit on the rink at one time? And so they're going to have to be operating in different places. But then also, then I'm going, would a rink have 2 Zambonis? Because that'd be awful expensive, because you can't. Anyway,
Well, granted, think about it.
we're not worrying about that part of it. We're just worrying about what the problem tells us. I'm not going to stress about whether the rink can afford 2 Zambonis or not, because that is outside of my realm
Yeah, you
of
could over.
concern. That is not my job.
Just one day.
How does it
1/6
take
180.
Okay, so we have Zamboni operator 1 and Zamboni operator 2. Zamboni operator 1 is 6 minutes. Zamboni operator 2 is 8 minutes. So now I'm looking, I need to make fractions based on how much they can do within one what? Minute.
1/6.
So he will be 1 over 6, he will be 1 over 8, and what will my total job together be? 1 over j. So I'm gonna have 1 over 6 plus 1 over 8 equals 1 over j. Common denominators of 6 and 8. Think about our multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4 is 24. So that is going to be my smallest number that both 6 and 8 will go into. Could I have multiplied 6 times 8 and used 48 as my common denominator?
Yes, but it'd be harder and you have to reduce.
I could have, but I've got bigger numbers and exactly. So I'm going to have to multiply by 4, multiply by 4. So I have 4 over 24. Multiply here by 3, by 3, 3 over 24 is 1 over j. 7 over 24 is equal to 1 over j. So 7j equals 24. Divide by 7, divide by 7. 7 into 24 will go 3. 3 times 7 is 21. Subtract, add a 0 and bring it down. 7 will go into 34 times. That'll be 28. That'll be a 2. Or like the book did. So basically, let me back up for a minute. How could I, when I have a number that looks like this, how can I change that into a mixed number?
You multiply the.
First of all, what is a mixed number?
It's
A whole
when
number.
There's a
fraction.
number.
A whole number and a fraction. And this, what is my whole number?
7.
3. 3 is my whole number. Remember, this is my whole number. What is my fraction?
3 7.
3 7.
Remainder over divisor, so 3 and 3/7. So what do I know 3 represents?
The whole number.
The whole number, and what am I talking about in this problem?
The
Minutes. So I know it's 3 minutes and 3/7 of a second, okay, or 3/7 seconds, or 3/7 of a minute. So in that situation, I could set it up and say 3 over 7 equals x over 60. 7x is equal to 180, and go through all that and figure out my seconds as well. Or I could just leave it as 3 and 3/7 minutes.
Does
Okay.
it have to be the mixed number?
You could either have it as a mixed number.
Or could it be a decimal?
So you could either leave it as a fraction, or you could calculate to minute and seconds. It's totally up to you, whichever you prefer. We're not going to be doing either. The main thing I want you to know is just how you set these up. So let's look at the next one. John can build a snowman in 30 minutes. Levi can build a snowman the same size in 20 minutes. What is my fraction? What are my fractions going to be? 1 over 30 plus 1 over 20 equals
1 over j.
what's my common denominator going to be?
10.
Mm-mm.
60.
Remember, it has to be a multiple of my numbers.
60.
60, good. So denominator is 60, so 1 over 30 is what over 60?
2 and 3. So it's actually 1.
5.
Because I have to
6.
multiply by 2 here, multiply by 2 here, multiply by 3 here, multiply by 3 here. So I have 5 over 60 equals 1 over j. What can I do before I cross multiply? If I wanted to, I could reduce and have 1 over 12. And then I can see that j equals what?
12.
12 what? What is our period of time we're talking about here?
12 minutes.
12 minutes. Good. So work problems, I'm going to set up 2 fractions that represent each individual, each machine, each whatever individually. It's always going to be 1 over whatever the number is you've been given, and it's going to be equal to 1 over j, and then you just solve. Okay, so those are work problems. All right, so I think we've covered pretty much everything that we need to cover. Evelyn's gonna go burn her book. Okay. On Thursday.
Oh, we saw Thursday.
On,
Should
we
have
still have Thursday. On Thursday, I'm going to have
A party.
Cookies.
It does start with a P.
A packet.
A packet. Yay! So on. Okay. So what I'm gonna do. All right. I don't want to make you cry on the last
It's
disc,
too late.
but too late.
Don't make me cry.
Okay.
I'm gonna
So
cry.
on Thursday, listen up. I'm going to be doing a spot check of your packets that we've dealt with. And remember, I think the only one that y'all really had to do was that ratio and proportion sheet.
Yeah.
So that, and then if you did the bonus work, there was a page of bonus work that I told you could do.
I did all of it.
Okay. So on Thursday, I'll be checking the bonus work if you want to turn that in for bonus points. If you have any test corrections or any assignments that are outstanding, I need those on Thursday. But on Thursday, I'm going to have a packet for you guys that says, hey, this is everything you need to remember from Algebra 1 because you're going to need it in either geometry and or Algebra 2. Okay, so we will be working on, and so it'll be something that it is not due.
It's a big review.
It's basically a review packet to help you. I know there are some of you that may need to brush up on some stuff before math next year. There may be some of you, and basically it's going to be something that it's going to be more of an individual accountability type situation. Because real quick, let me just kind of give y'all this spiel. We've got 10 minutes before the bell rings, so nobody's going anywhere fast. Okay, so in my experience having taught ACT prep, okay, not everybody in here, I recognize y'all may not all take the ACT, and that's just fine. I'm not saying you have to take the ACT. If you're planning on going to college, you do have to take the ACT. Now, there are some schools that are going test optional now. Now, whether or not that will continue, I don't know. Because of COVID, what happened was places got shut down so people could not take ACT tests. There are still some places in the north and out west that places are still shut down and they can't do testing. Therefore, for kids to apply to college, they didn't have ACT scores to apply to colleges. So a lot of colleges are doing what they call test optional. What that means is you can get in, you can apply based on basically GPA, and these are the classes that I've taken. So you don't necessarily have a test score to go on, which is good unless you're looking for scholarships. Okay, so a lot of schools are still requiring ACT to qualify you for scholarships. Some schools have actually already done what they call their own testing methods, and they're like bringing kids to campus to interview them and do their own type of testing to see what they would qualify for. But a lot of schools are still using ACT to qualify for scholarships. Having said that, who knows what things are going to be when y'all are graduating? Who knows where things will be with testing? Who knows where y'all are all going to go? I didn't realize until recently that my daughter was like, I want to go at least 2 hours away, and she wants to go nowhere in state. She's like, I want to be able to go live kind of on my own for a little while and see what that's like. And so,
Could you tell her that it actually costs more to live out of state?
well, and that's why scholarships are important. That's why she's working on her ACT, because right now with the school that she wants to go to, basically all her tuition will be paid because of her score on the ACT. So that's what I've told her. If you want to do that, that's great, but it does cost more. And so you've got to be able to be ready for that. All of my saying this is because the ACT is testing stuff that you started learning in about 7th grade. Okay, so when you sit down to take a test, whether you're in 10th or 11th or 12th grade, it is testing you on content that you would have learned from about the 7th grade until mid-year of the 11th grade. Because, and especially on the math. Okay, well, math and English are the biggest ones because English is covering all of those grammar skills that you started learning in middle school grammar. Capitalization, punctuation, prepositions, prepositional phrases, complete sentences, all that good stuff. Okay, so all the grammar you've been learning, that's why I keep telling y'all with math, you've got to remember this because everything builds. So on the ACT, you have some pre-algebra and algebra 1. You also have about as much geometry in algebra 2. So if you haven't had algebra 2, or you haven't had geometry and you go take the ACT, you can't expect to do great on the math because you're only going to know how to do the algebra. But recognizing that when you do take the math portion of the test, one of the things I've seen, especially with kids, like I have one kid that took my class and he said the hardest part for him was the more simple math because he's taking calculus now. So to go back and remember, oh my gosh, this stuff is so simple, but he's so used to doing such high level math, and that's not on the ACT. What's on the ACT is Algebra 1, Geometry, Algebra 2 with a little bit of trigonometry. So Algebra 2, the end of Algebra 2, you do trig. Does anybody know what trigonometry is?
Yes.
What?
I don't know what it is.
The study of what?
Study of numbers.
Triangles. How scary are triangles?
Very.
Triangles, not as scary as circles are. Triangles aren't scary, okay? So we hear all these math things and we go, oh, I can't do that. Yeah, you can. It's going to be okay. But my purpose in telling you this is what we have done this year is your foundation for geometry and Algebra 2. You have to have those two maths to graduate, okay? So whether you're taking the ACT or not, you need your foundation in algebra for geometry and Algebra 2. Because just this year, not too long ago, we're in geometry and I said, okay, how are we going to solve this? I've got two equations and I've got two variables in my equations. How have we learned? How do we solve equations that have two variables? How do I make it to one variable? What was that unit called? How many equations did I start with? I had two equations. I'm just going to make up something real quick. 2x plus 4y equals 9 and x plus
I can't even remember what
3y equals 4. You remember when we had two equations and they both have x and y? And I had to figure out, hey, how can I get rid of one of my variables? That was called systems of equations. Okay, so in geometry, we're using systems of equations. So it's not something that you just, hey, I've learned this in algebra, check, I'm done with it. You're going to see systems of equations in geometry. You're going to see systems of equations in Algebra 2. Okay, so what I'm going to do is on Thursday, I'm going to have a packet for you that says, hey, this is what we learned in algebra. And these are the things that you need to know how to do. And if you say, and you can go through and go, yeah, I know how to do that. I'm good with that. Oh. Okay. So hopefully you don't go, ooh, the whole packet because, but anyway, but the main thing is, and like I said, it's personal accountability. Okay. Because who's in charge of your education?
Me.
No, your mama is not in charge of your education. You are. Okay. You're the one that has to decide what you're doing with your life, right? And I want you to know that education is knowledge that no one can take away from you. Okay. Nobody can take away what you know. Nobody can take away. Now you can lose your job, you can lose your house, you can lose all kinds of things. You can have stuff taken away from you. But what you know how to do, nobody can take that away from you. So that's why it's important for you to stop and say, okay, am I just going to skate by and do the minimum I have to do to get by? Or am I actually going to try to do better? Okay, so that's what you've got to think about. So that's my purpose in giving you the packet. It's not to freak you out and make you go, oh my gosh, I don't know any of this, but it's for you to go, hey, this is what I know. Because if you leave algebra not knowing it, and then let's say I'm doing ACT prep with you and I'm going to say, remember how to do this, and you go, no, well, you either have to relearn that or you just miss it on the ACT. Okay, you can't go back and relearn everything from 7th to 12th grade in like a 4-week ACT class. You can't go back and relearn 5 years worth of knowledge. Okay, so that's why I'm saying use this time now to learn it. I challenge you guys to, you're not gonna know 100% exactly what to do every time, but be familiar with it. Don't just go, hey, I'm just doing this to get by for that assignment, or I'm just doing this to get by for that test, and then have a brain dump and it's gone. Okay, because you're going to need it some way, some shape, some form. I had a student earlier was talking about, she works at a horse place, and she said something about there was something she had to do, and she had to do something at 260 degrees. And she said, she said she literally stood and she was like, okay, because obviously geometry, we're dealing with degrees. We're talking about angle measurements and degrees and stuff. So she said she was facing, she said she went, all right, there's that. So this is 180 degrees because what do you know a circle is? 360. Okay, so whether you've done like
1/2 of that is 180.
So if that's a 360, that's a 180. So that means each of these are 90, right?
Yes.
So if from here to here is 90 degrees and from here to here is 90 degrees, this total is 180. So if she was trying to do 270, then that means she needs to go another 90 degrees. So she said she was facing it. She goes, all right, 90, 90, 270. There you go, that way. So, I mean, there are some practical things to it that you may actually see that you actually have to do in real life, okay? So anyway, so I just want to encourage you guys. Are you going to want to sit home and work on this packet over the summer? Absolutely not. That's not what I'm saying. I want you on Thursday, we're going to kind of go through it, talk about each of these things. And I want you to kind of take on that personal responsibility of saying, hey, if this is something that I don't know, are you going to take the time to figure it out for you later so you don't have to struggle with it again? Okay. So that will be Thursday. I will have that for you and we will wrap up the year. Okay. I'm proud of you guys for all of your hard work and for sticking with stuff. Evelyn.
Is there gonna be food?
Is there going to be food? There might be something to snack on.
My brother asked me to play this at each time I into class. I only played it for a few seconds, but I did get this.
You got a couple of beats in there. You did. All right. Y'all have a great afternoon. See, no.